Welcome back from the ad break, and let's continue with our lesson. So now we are going to move on to those application questions. Now the first one there says, Buto wants to fill this rectangular shaped plastic container with water. How much water will she need? So we have been given a container that, of course, yes, is a shape of a rectangular prism. And as we can see there, we have been given the length, we've also been given the breadth, and of course we have been given the height of this rectangular shaped container. So for us to find out how much water Buto will need, we need to find out the amount of water that can go into this container. Remember, Buto is going to fill up this container, which means that the capacity of this container will be the volume of the water, which will be the one that occupies this container. So let us calculate the volume using the dimensions of this rectangular shaped container. So this is a shape of a rectangular prism, which means that the formula is going to be our length multiplied by our breadth and multiplied by our height. So the volume of this rectangular prism is going to be, now the length there is 20 centimeters. The breadth we've been given as 15 centimeters. And the height is 10 centimeters. So when we multiply these three dimensions together, that is 20 multiplied by 15 multiplied by 10. That is going to give us an answer of 3,000 centimeters cubed. So that means that Buto is going to need 3,000 cubic centimeters to fill up that container. Remember, let's now convert our cubic centimeters into liters, because that's actually where we are going to see how much water she is actually going to need. So when we are looking at this 3,000 centimeters cubed, remember that 1,000 centimeters cubed is equals to 1 liter. So what does this mean for 3,000 cubic centimeters or centimeters cubed? That means that Buto is going to need, you can write that down and say that Buto will need, so now we are going to take this 3,000 centimeters cubed and convert it to liters. So how are we going to move from 3,000 centimeters cubed to liters? So we can see there that if we multiply our 1,000 by 3, we are going to get 3,000 centimeters cubed, which means on the other side or the right-hand side, we need to multiply that by 3 as well. So that is going to give us 3 liters, which means that Buto will need 3 liters of water to fill that plastic container. Let's move on to the second question. Now, our second question there, we have been given a triangular prism. Now, a triangular prism, remember, has the triangles as the bases, so that is the top and the bottom, and of course we have the height of the prism there. So let's calculate the volume of this prism. Do you remember what the formula is for a triangular prism? Yes, it is 1/2 multiplied by the base multiplied by the height of the triangle, which is the base. Remember, volume is just the area of the base multiplied by the height of the prism. So here we have the area of the base, which is 1/2 multiplied by the base multiplied by the height, and we are going to multiply this by the height of the prism. So the volume of this triangular prism is going to be 1/2 multiplied by the base, and in this case the base of our triangles is 8 centimeters, and we are going to multiply this by the height of the triangle, and that is our 3 centimeters. And we are going to multiply all of that with the height of the prism, which is 10 centimeters. So what is going to be the volume of this triangular prism? That is 1/2 multiplied by 8 centimeters multiplied by 3 centimeters, and all of that is going to be multiplied by 10 centimeters. We are going to get an answer of 120 centimeters cubed. And remember, it is centimeters cubed, and we are cubing here or using cubed because we are working with volume. Our next question there is a Rubik's Cube. So let's see what is happening there. It says there, Andile wants to calculate the volume of this Rubik's Cube. What will be the volume of this cube if one surface area of the cube, if one surface of the cube is 9 centimeters squared? Now we know when we are given centimeters squared, that is the area of this cube. So we are being told that one surface, so we'll take that blue surface there just to understand what we are talking about. We are told that that surface is 9 centimeters squared. Now, if that surface is 9 centimeters squared, what is the size of one length of that? Because this is a cube, if we just get just one length, then we know that we can take that length and cube it, and that will give us the volume of this Rubik's Cube. So let's work with the formula. Do we remember what the area of a square is? Because remember, the surface of the cube is a square. So when we take the area of a square and we use that formula, we can find out what the length is. Now, the area of a square is the length squared. And since as well we've been given the area, which is 9 centimeters squared, we can use that area to find out what one of the lengths is. So now we have 9 centimeters squared is equals to the length squared. If I want to know what the length is, we are going to now put a square root under, put the 9 centimeters squared under a square root. And we know that that could be either the positive or the negative answer of the square root of 9. So the square root of 9 is either a positive 3 or a negative 3, which means we have the length as either a positive 3 centimeters or a negative 3 centimeters. But because we are working with a length, that means that our length is actually the 3 centimeters. So 3 centimeters is equals to our length. Now that we have the length, we can calculate the volume of this cube. Now, do you remember what is the formula for the volume of this cube? Yes, it is the length cubed. And now that we have the length, that means we can calculate what the volume is. So our length there is 3 centimeters cubed, which means that if we take this 3 and we cube it, then we are going to have an answer of 27 centimeters cubed. And that is the volume of this Rubik's Cube. Let's go over to our last question, which is a complex figure that we are required to calculate the volume of. Now, if we are looking at this figure now has 2 shapes that we need to calculate the volume of. And the 2 shapes there is, well, as we can see, the bottom part there is a rectangular prism, and the top part there is actually half of a cylinder. So that means that we are going to be calculating 2 volumes to find the volume of that complete shape. So we are going to be taking the volume of the rectangular prism, and we are going to add this to the volume of the half of the cylinder. And that, of course, is going to give us the total volume of this shape. So if we have the total volume for the rectangular prism, the volume is the length multiplied by the breadth multiplied by the height. And we are going to add this with the volume of half of a cylinder. Now remember, half of a cylinder will be the formula of the cylinder, and we are going to divide that by 2. So that is going to be the pi multiplied by r squared multiplied by the height. And this formula is going to now be divided by 2 because we are working with half of a cylinder. So the total volume there is going to be our length, which when we look at our rectangular prism, our length is the 12 centimeters. We're going to multiply this by the breadth, which is our 8 centimeters. And as we can see, remember, because this is a rectangle, it means that this 8 centimeter is also the length or the breadth on this side as well. And we are going to use that later when we are looking at our half cylinder. So we can see that that was the 8 centimeters. And of course, we're going to multiply this by the height, which is our 3 centimeters. And that is the volume of our rectangular prism. We are going to now add this to pi, which is 3,14. We're going to multiply that by the radius squared. Now going back to our figure, the breadth of the rectangular prism is also the diameter of our cylinder. And since as well we know that we are only looking for half the diameter, that means we are only looking for the 4 centimeters, which is the radius of that half cylinder. So the radius there is the 4 centimeters squared. And we're going to multiply this by the height of the half cylinder. And we can see that the height of the half cylinder is the same as the length of the rectangular prism, which means that is multiplied by 12 centimeters. Of course, all of this is going to be divided by 2. And the reason why we are dividing this by 2 is because we are working with a half cylinder. So the total volume for this prism is going to be 12 centimeters multiplied by 8 centimeters multiplied by 3 centimeters, and that is going to give us 288 centimeters cubed. Of course, we are going to add this with our 3,14 multiplied by our 4 centimeters squared multiplied by our 12 centimeters, and when we divide all of this by 2, that is going to give us an answer of 301,44 centimeters cubed. And of course, if we add these two values together, that is going to give us a total volume of 589,44 centimeters cubed. And that is going to be the total volume of this figure, which is a half cylinder combined with a rectangular prism. Let's quickly go to an ad break and then we'll see you just now.